Let's continue. A police van moving on a highway with a speed of 30 km/h. The velocity of the van, we can take as VV. Velocity of van is 30 km/h, around 25 by 3 meter per second. Meter per second. It's a bullet at a thief's car speeding away in the same direction with a speed of 192 km/h. So the velocity of the car is 192 km/h. When you simplify, you will get around 160 by 3 meter per second. Meter per second. Then the muzzle speed, the initial speed of the bullet is 150 meter per second. Bullet speed of the bullet is 150 meter per second. Then what speed does the bullet hit the thief's car? So here various relative motion we have to see. First of all, the thief's car is in relative motion with the policeman. VCV we can take as VC minus VV. So VC minus VV, you will get around 45 meter per second. Then, in fact, the car is moving with this particular velocity, relative velocity, towards the car moving with this particular velocity. Now the bullet is reaching with a velocity 150 meter per second. Therefore, now we need to calculate the relative velocity between the bullet and the car. So relative velocity between bullet and the car, when you take, we can have the relative velocity of the bullet with respect to car. Car is already in relative motion with one. From there only the bullet is fired. So VB minus VCV, relative velocity of the car with respect to one, we need to take. So that is equal to, we will get a 150 minus 45. 150 minus 45. So you will get the relative velocity of the bullet with respect to car. Now question 19. Suggest a suitable physical situation for each of the following graphs. The first graph is a position time graph. So position time graph being straight line means the object is at rest. Here an object is at rest. Here again the object is at rest. Now in between you can see the velocity of the object uniformly increases, then decreases. But second time it is at rest at a negative position. So what physical situation we can consider here? Here you can take a ball which is at rest. That means the initial part of the graph. From there, the ball moves with the uniform velocity. So, and here assume there is a wall. Now from the ball bounces back. Ball bounces back, and little behind it becomes rest. That means if initial position, if you take 0, then some negative position, it becomes rest, and it moves with a particular uniform velocity again. So that is the situation. Now graph B is a velocity time graph. Velocity time graph, already we have seen this kind of a graph. Here it has a velocity. Then at this point velocity becomes 0. After getting velocity 0, the direction of velocity changes to negative direction, and here the velocity becomes maximum. And once the velocity becomes maximum, suddenly the direction of velocity changes. Velocity becomes positive. Here it was maximum negative, then positive, but it is slightly less than initial velocity. So what situation we can take here? So initially the velocity is high, so we can assume that an object is thrown upwards with an initial velocity v. When it reaches the maximum height, its velocity becomes 0. Then it falls back and hits the ground with the same velocity, but the direction is opposite. The moment it hits the ground, direction of it bounces up, so that direction of its velocity becomes positive. From there, when it goes upwards, its velocity decreases and becomes 0 here at the highest point. From the highest point, the object begins to fall, so that its velocity increases in the negative direction to negative v. The moment again it reaches the floor, it bounces back so that its velocity becomes positive. So what is this graph actually represent? Graph represents an object thrown upwards, but falls back and bounces repeatedly from a surface. And from each bounce, certain amount of velocity is lost. That is why you can see the size of the graph decreases. But you can see these lines are parallel, which indicates that the acceleration is slope of the graph. Acceleration is constant. We know acceleration is g, 9.8 meter per second square. It is constant. So this is a condition in which an object is thrown upwards, falls back and bounces repeatedly, and in each bounce certain amount of velocity is lost. Now come to part graph C. Graph C, you can see here is acceleration time graph. Acceleration time graph straight line, which means it is straight line and along the axis also. So we can consider initial acceleration is 0. The object is moving with the uniform velocity. Then momentarily it got accelerated, decelerated, then again it goes with the same velocity. So what kind of a situation you can consider? Here also we can take a ball thrown to a wall, which is going with the uniform velocity. Okay, during the collision, momentarily its velocity becomes suddenly 0, changes, then it bounces back with the same velocity. So during this interaction with wall, there is a sudden decrease in velocity, then the velocity increases back, then it bounces back with the same velocity. It can be considered as a ball thrown to a wall, bounces with the same velocity. Now, question 20. Again, one-dimensional motion and harmonic motion. The question says that you will study about the details of this in chapter 14. So just to we will see the answer, that's only, nothing more. So here t is equal to 0.3 seconds, maybe this point t is equal to 0.3 seconds. 0.3 second, no, even before that. That will be 0.5, 0.3 we can take 0.3 seconds. Then next to 1.2 seconds, it will come here 1.2 second, then minus 1.2, maybe here minus 1.2. At the same time, I want to remind here time cannot be negative. Now here, find the sign of position, velocity and acceleration. Here in harmonic motion, okay, you have to understand that. Later we will prove, you will see in detail. Acceleration is always opposite to displacement. Acceleration is always opposite to displacement in harmonic motion. Okay, so just if we see the sign, first case t is equal to 0.3 seconds, then we can see according to the graph given, the position is negative. position negative. Position is negative. If the position is negative, definitely velocity also will be negative. And position and acceleration are always opposite. So acceleration will be positive. Now in case 2, 1.2 seconds. So in 1.2 seconds, we can see position positive. Position is positive. Then position positive means velocity is also positive, and acceleration is opposite to displacement. Therefore, acceleration is negative. Then in third case, minus 1.2 seconds, position is given negative position. Position negative means velocity is also negative. Then velocity negative means acceleration is positive. And here you can find one explanation that here velocity is positive by taking negative time. When position is negative, time is also negative, then velocity will be positive. So that way also we can see the explanation, but usually we do not consider time negative. Okay, this is something happened before an event. That's all, before another event. So like that we can see, and details as given in the question we will see later in chapter 14. Next, question 21. Graph is given. It's a position time graph for one-dimensional motion of a particle. Then, in this case, when we see three intervals are given there, then those three intervals, when we observe, we can see here equal intervals, means the time is same for all three cases. Here, time, same time. Something happened in same time. Position time graph is given. In which interval is the average speed is greatest, and in which it is the least. Give the sign of average velocity in each interval. Okay, from position time graph, you can calculate the average speed by taking the slope. So here you need to take the slope. Here also we can take the slope. Here also slope. So when you take the slope, for a graph, slope is like this: y part divided by x part. Y divided by x. If y is large, slope is large. And slope gives velocity. So is for which case out of these three y is large. All the case horizontal distance is same. T is same, we have seen. So y is maximum in the case of third one. So you can see there. In the third case, the maximum average velocity is there, while in second case it is the least. Third case it is maximum, so here it is maximum, and it is minimum in the second case. Minimum in second case. Then give the sign of average velocities. You can see here your position is positive, so average velocity is positive. Here also it is positive, while here it is negative. Same. Now question 22 is a similar question. This time we have speed time graph. Okay, speed time or even velocity time you can take like that. Here also the time intervals are equal. Now, in which interval the average acceleration is greatest? We know from velocity time graph you will get the acceleration by taking the slope. So in which case, as I mentioned in the case of the previous graph, in which case you get a maximum slope here, that will you have to see here. We can draw the slope like this. So we can see maximum maximum y part is in the case of, in second case it is minimum in case D. So second case it is maximum. Second case it is maximum, and third case it is minimum. Maximum, then third case minimum. Then next you have to see choosing the positive direction as the constant direction of motion, give the sign of velocity and acceleration in these intervals. So position is positive, velocity is positive. Okay, because of our graph is only in positive direction. So when you take velocity, velocity is positive in all three cases. Velocity is positive. Come to the acceleration. Acceleration, when we think, you can see first case slope is upward, third case also in the starting it is going upward, and only in second case the graph is downward. So in second case it is negative. Second case it is negative. Other two cases it is positive. And what are the accelerations at points A, B, C, and D? So take point A is almost horizontal. When you take B also at this highest point, it is horizontal instantaneously. C also horizontal, D also horizontal. Velocity time graph horizontal means acceleration is 0. So at these points, the instantaneous acceleration is 0. Now, next question 23. A three-wheeler starts from rest, which means u equal to 0. Three-wheeler starts from rest, accelerates uniformly with the 1 meter per second square. Acceleration is given 1 meter per second square. On a straight road for 10 seconds, time is 10 seconds. Then moves after 10 seconds, it goes uniformly. So whatever velocity it has at the end of 10th second, it retains the same velocity afterwards. Plot the distance covered by the vehicle during nth second versus n. So when you calculate nth second, that n represents time. So whatever graph you have to draw, it is not a position time graph you have to draw. You have to draw a graph between time and the distance traveled in each second. Each second means first second, next second, third second, fourth second, fifth second, like that. Okay, now, so here we need to use the formula for a displacement in nth second, which we have derived already. So xn minus 1 is equal to, our formula is u plus a by 2 into 2n minus 1. 2n minus 1, that is a formula. There u is equal to 0 and a is equal to 1. Now in that formula, okay, this one we can take as dn, displacement in nth second. Now we can substitute here n equal to 1 and all other values. When you substitute n equal to 1, you will get d1. That means distance traveled in the first second. d1, you have to substitute and find out, you will get around 0.5 meter. Then next you can take n is equal to 2, n equal to 3, like that. 2, 3 values you can calculate, and finally you can take n is equal to 10. Then you will get the value of B10. B10. You will get around 9.5. 9.5 meter. Then next, what will be the value of D11? D11 will be again 9.5 meter only. Then what is the reason it is again 9.5 meter? Because after 10 seconds, the three-wheeler travels with the uniform velocity. That is the reason. So now, with these values of D1, D2, D3, etc., you have to plot a graph. That is the graph. This graph is different, as I mentioned before, so that what you need to understand very, very properly. So here you can see graph. We can start from first second onwards. So this point will be 0.5. Then maximum value you will get to 9.5. 9.5. So you will get a graph like this, starting from 0.5 up to 9.5, and it happens at the 10th second. It becomes 9.5. Then afterwards we can see value cannot be increased because of uniform velocity. Afterwards, every time D11, D12, D13 all will be value 9.5 only. So graph will be horizontal. Next question 24. A boy standing on a stationary lift throws a ball upwards with the maximum initial speed he can equal to 49 meter per second. That is U. How much time does the ball take to return to his hands? Okay, so you have to use the formula V is equal to U plus 80. V is equal to U plus 80. Find the value of t from that equation. V is equal to 0. Find the value of t, and the time taken will be 2t to return back. V is equal to 0 in this case. So find the value of 2t, that is the time taken to return back. Now, if the lift starts moving up with the uniform speed of 5 meter per second, and the boy again throws the ball with the maximum speed he can, how long does the ball take to return back his hands? So again, the time will be same. So what is the reason the same time? So here, the lift and the ball. Okay, when you see, when you throw it at the initial time, there is a relative velocity, and finally when the ball is caught, when it returns back, that time also the same relative velocity is there. Therefore, time taken will be same. In the first case, we can take it just goes upward, then returns back to hand. Returns back to hand. Okay. Now, in the second case, what happens? Suppose again from the same position, the lift starts motion from the same position it is thrown, and it goes upward, but now it will go more upward because it has an initial velocity which is equal to velocity of the lift. Then it returns back. So by the returns back here, the lift will reach here because lift is moving upward. Lift will reach at this point. So this total path length will be same. Therefore, the time will be same. But when we give the explanation, we can say the relative velocity is same in both the cases, both the time. So time will be same. Here also, relative velocity, relative initial velocity is same at the time of the ball thrown when it returns back. Here also, relative velocity is same in both the time. So same time will be there and the length of the path will be same. Here some extra distance it goes upwards, but the same distance will be reduced here as the lift goes upwards at the time the ball is caught. Now question 25. We can see from the diagram a child is running between the parents with a speed 9 km per hour, and father and mother are at a distance 50 meter apart, and the speed of the belt 4 km per hour, and we need to think about an observer standing stationary outside, or an observer what he observes. That is what we have to see. The first case we can see the child running in the direction of motion of the belt. So what happened here? We need not take any relative velocity concept. Directly we can think. If suppose the belt is stationary and child is running, then the observer will see 9 km per hour speed. Now, if only belt is in motion, child is at rest, then the observer will see the child has a speed 4 km per hour, that which is equal to the speed of the belt. Now both happens. Child runs, belt moves. So both these velocities will be observed by the stationary observer. Therefore, the velocity will be 9 plus 4 kilometer per hour. Now, next part B, the speed of the child running opposite to the direction of motion of the belt. What will happen when the child running opposite to the direction of belt? Then child is running in the opposite direction, so its velocity becomes minus 9. Belt is again going forward, B. So, sorry, it is 4. So the resultant velocity, how much will be observed? Minus 9 plus 4, you will get minus 5 kilometer per hour. So what is the meaning? Minus 5 kilometer per hour, which means the observer will feel that the child is going backwards with minus 5 kilometer per hour. Okay. When the backward in the sense opposite to the direction of motion of the belt. Then next, time taken by the child. When you think about time taken by the child, you need to just to see that what is the distance traveled by the child and what is the speed of the child. So distance traveled by the child is 50, and time is equal to distance 50 divided by the speed of the child 9 into in meter per second. We need to calculate 5 by 18 will be the time taken by the child, because the child is running this particular distance with this particular speed. There the speed of the belt is not a factor. Then which of the answers alter if the motion is viewed by one of the parents? So if parent is observing, so you see both the parents are sitting inside the belt, they don't experience the speed of the belt, they will just see the speed of the child only. So what happens? So in answer A and B, answer to A and B, we consider the speed of the belt also. So parents will not experience the field of the speed of the belt as they are inside. Therefore, answer A and B will alter. Then next, question 26, one graph is given. So two stones thrown simultaneously from the edge 200 meter high we can take as initial position x naught is equal to 200 meter. 200 meter. Okay, now speed 15 and 30. Initial speeds, that is 15 and 30. Okay, so we can take initial speed 15 and 30, u1, u2, like that. Now verify the graph. The graph you have to verify whether the graph is correct or not. Neglect air resistance, no need to consider any other force like that. Okay, then stones do not rebound from hitting the ground. Take g this much at 10 meter per second square and give the equations for the linear and curved parts of the graph. First of all, you have to see what is this graph. This graph is the graph between relative position. Here you can see it is x2 minus x1. Relative position of the two stones and the time. So graph between relative position of the two stones and the time. That is the graph. Then in such a case, one more point here I want to specify, that is about the position. There is a small print error in the graph. You can see there between 2 and 4, 2 divisions are there. But here actually this is not the correct 0 point, because between 0 and 2 also we need 2 divisions, but that is not shown in the graph properly. That's a print error. Please understand that. Okay, so accordingly, there is a small problem in the graph when you try to find. So please understand that this position is, the graph is slightly shifted towards right hand side. That problem is there because this origin is not taken properly there. So understanding that, that should be in your mind. Okay, so now we are going to verify the graph. So when you verify the graph, okay, first we will write the equation for first case. X1 is equal to x naught plus ut plus half at square. X naught is equal to xt plus ut plus half at square. X naught plus ut plus half at square. So x naught is equal to x1 is equal to x naught plus ut plus half at square. Now we can take any particular time, we can take here. We can take 4, 6, because we want to verify the graph. So we take for time t equal to 4 seconds, we take t is equal to 4 seconds, and g acceleration is g, we have to take minus 10 meter per second square, because both the stones are thrown upwards. So then find the value of x1. X naught we have to take 200. You will get the value of x1 is around 180 meter. Then next you calculate x2 using the same formula. You have to take 30, a minus 10, x naught 200 again, So you will get the answer 240 meter. Now take x2 minus x1. x2 minus x1 is equal to, you will get a 240 minus 180, around 60 meter. You will get 60 meter. That means that time t is equal to 4 seconds, it should be 60 meter. That is the result we obtained. We need to get a 60 meter in this case. But at the same time, I told you there is more problem for the graph. Okay. So here, when you take 4, when you take 0.4 there, it goes straight. We need to get 60, but you know that one division difference will come. It is due to print error, please understand. Otherwise, you will get this corrected 60. Because of that 1 point print error is the reason. So from there, okay, we can say the graph relative distance, so time and relative distance is correct, we will say, okay, but again I repeat, don't state that it is wrong. There is a small printing problem. Now, next, we need to see now the equation for the motion. When you take the equation for a motion, okay, we again take the equation for x1, x2, etc. So x2, we can take x2 minus x1 in the form of equations. So what is the value of x2? x2 is equal to 200 plus 30t. That's the value of u there, minus half, acceleration is 10, and this value of t I will just write as t only, t square. That is the value of x2 minus now value of x1. Value of x1 will be 200 plus 15t minus half 10t square. So if you directly take equation, then this is the difference between x1 minus x2. Now simplify this. When you simplify, you will get the answer 15t is the difference. That means x2 minus x1 is equal to 15t. So look at this equation. This equation is a first degree equation. First degree equation, if you draw the graph will be a straight line. So that is the reason graph between time and relative position x2 minus x1 is a straight line. You are getting a straight line here. So that also we have explained. First we proved position is correct. Next we proved graph should be a straight line. Graph between x2 minus x1 and t is a straight line because the equation is a first degree equation. But you can see there after 8 seconds, graph is not a straight line. So what happens to the graph at 8 seconds? Why it is not a straight line after 8 seconds? That also we need to give an explanation. So we will try to calculate what happens at 8 seconds. Take t is equal to 8 seconds. Then once again you find the value of x1 and x2. We can substitute t equal to 8 seconds, then find the value of x1 and substitute the value t is equal to 8, then you will find the value of x2. So at that situation you can see there x1 equal to 0 and x2 you will get the value. Now taking x1 0, use this equation. If x1 is 0, what is the meaning x1 0? x1 0 indicates that the ball which is thrown upwards the first stone returns back to ground. It is thrown from a cliff, it returns back to ground. That is the meaning x1 is equal to 0. While the second stone is still remaining uh, in the atmosphere, sky. Okay. Now, if it is only x1 is 0, if it is only x2, then what will be the equation? X2 is equal to, the equation is 200 plus 30t minus half 10t square. So it is actually x2 minus x1, x2 minus x1 equal to. Now here in that formula substitute x1 equal to 0. If x1 is 0, then this is the equation for x2. Only x2, only second stone is in motion. Then if only second stone is in motion, then this is not the formula x2 minus x1 is equal to 15t, but the formula is given by this equation. And this equation you can see there, it is a second degree equation. Second degree equation, if you draw the graph, then you will get a parabola. So what happens after 8 seconds? At 8 seconds, the first stone is at the ground. So it is no longer in motion. Only second stone is in motion. So for x2 minus x1, you need to consider only the second stone. So when you consider only the second stone, the equation is a second degree equation. Second degree equation is a parabola. That is the reason the graph is a parabola after 8 seconds. Okay. Now, next question 27. Here in question 27, you have speed time graph is given, velocity time. Okay. As it is one-dimensional motion, you can see in your book in many places it is mentioned speed. You can take it as velocity time graph. Okay. And obtain the distance traversed by the particle between 0 to t equal to 0 seconds to 10 seconds. T is equal to 2 seconds to 6 seconds. And what is the average speed of the particle over the intervals in A and B? Okay, so let's see how to solve. From velocity time graph, you can calculate the distance traveled by the body by taking area. So case A we are going to solve now. Case A, area is equal to half BH. Half BH is equal to half into base is 10, height is 12. So distance traveled by the particle during 10 seconds is 60 meter. Then what is the average speed? Average speed or average velocity is equal to total distance divided by total time. So you have 6 meter per second is the average speed. Now come to part B. T is equal to 2 seconds to 6 seconds. T is equal to 2 seconds to 6 seconds. If you want to calculate, then here at 2 seconds we have to take the point corresponding to 2 seconds. Then here the point corresponding to 6 seconds. So how we can calculate this? For convenience, we can divide the graph into two parts. Here, we can take the motion in two parts. The first case, you can take the motion from 2 to 5 seconds. Next, we can calculate the motion from 5 to 6 seconds. So, how you can calculate distance traveled from 2 to 5 seconds? You can calculate by taking the area of this trapezium. But if you want to calculate the area of the trapezium, you should know the length of the parallel side. You don't know the velocity at this point, which you need to calculate. So if you want to get the velocity, first you should calculate the acceleration. You will get acceleration from the slope of the graph. Height is 12, base is 5. So acceleration is 12 by 5 meter per second square is the acceleration. Now, what is the velocity at 2 seconds? You can use the formula V is equal to U plus AT. U is 0. A is 12 by 5. And T, 0 to 2 seconds means T is 2. So, velocity at that point is 24 by 5. So, now take the area of the trapezium. Height here is 24 by 5. And height of the second side is 12, and here 3 is the height of the sea. So calculate the value. So yes, from 2 to 5 seconds, you will get the answer around 25.2 meter. Then next, the displacement from 5 to 6 seconds. To calculate displacement from 5 to 6 seconds, you can use directly the formula S is equal to ut plus half at square. And how much is u? U is 12 into how much is time? We are calculating from 5 to 6 seconds only. So time will be 1 second. Then here you have to see acceleration will be negative, because you see the same slope will come but in the negative direction. So minus 12 by 5 will be acceleration into t square. So you will get the answer around 10.8 meter. Now ultimately we need to calculate the distance traveled from 2 to 6 seconds. So you have to add both the distances. You will get the answer around 36 meter is the displacement from 2 to 5 seconds. Here once again you need to calculate average speed. Average speed is equal to total displacement divided by total time. Total time is 2 to 6, so 4 seconds you will get the answer. That's about question 27. Now come to question 28. Question 28, again you can see there that is a velocity time graph. Velocity time graph, which is a curve. Velocity time graph curve, okay, means the motion is non-uniform acceleration. That is the first conclusion you have to reach here. Motion is non-uniform acceleration. Then the question, which of the following formula are correct for describing the motion of a particle over the time interval t1 to over the time interval t1 to t2? That's the question. So the first graph, xt2 is equal to xt1. This is final position. This is initial position. Is equal to v of t1 into t2 minus t2. T2 minus t1. So what do you have to take? V of t1 means initial velocity u. T2 minus t1 is the time interval t. T2 minus t1 is the time taken. So that can be taken as t. Then Vt1 means the initial velocity u plus half a t square. So what is that formula? That formula is actually x is equal to x naught plus ut plus half a t square. And this formula, or so in simple terms, that formula is s equal to ut plus half a t square. Okay. So in such a situation, you can see that formula is applicable only for uniformly accelerated motion. But this is not uniformly accelerated motion. So it is not applicable. Formula is applicable only for uniformly accelerated motion. Then take the part to B. What is that formula? Vt2 is equal to Vt1 plus A into T2 minus T1. What is that formula? That is V is equal to U plus AT. Again, V is equal to U plus AT also applicable only for uniformly accelerated motion. And our case is non-uniformly accelerated motion. Now, part C, V average is equal to x2 minus x1 divided by t. Okay, average velocity is equal to total displacement divided by total time. It is applicable for all kind of motion. Then next, part D, A average is equal to V minus U divided by T. A average is equal to V minus U by T. Average velocity we can calculate. Okay, so that is possible. Then next, x2 xt2 is equal to xt1 plus V average into t plus half into A average into t square. So here also you see when you take A average means only one value. Average value is a single value. Average value single value means acceleration is constant. Only single value. If acceleration is constant, then we cannot apply in this case. So question is not possible. Next, part F, xt2 minus xt1 means of final position minus initial position means displacement equal to area under Vt graph. That is correct for all the cases. So that statement is correct.